Hey guys, welcome back to Learn Python the Hard Way. Today we're going to focus on exercise 28, where we take a closer look at Boolean expressions and also practice working with Boolean expressions. So in the previous exercise we learned the basics about working with logic and how to basically read different truth tables. Today we're going to go a little deeper into this topic and take a look at different Boolean statements and how to evaluate those. So Boolean logic is used in a lot of different places when we get into more complex programs, and it's a very fundamental part of computation. So in this exercise we will build on top of what we learned last week in the previous exercise, and we will evaluate whether a statement is true or false. And in order to do that we have here a number of different expressions. And before even running that, we should evaluate whether a statement will be true or false. And as we go down the list, we can see that those expressions become more and more complicated. And in order to solve, especially the more complicated topics, there are some helpful tips that we can follow. So for example, if we take a look at some of the later ones here, a good approach is the following. We should first of all find an equality test, so equals, so the equal and the equal sign, or not equals, which is exclamation mark equals. And when we take a look at that, then we would replace it with this truth. So for example, if we take a look at the last expression here, testing equals testing, we would evaluate that first. And in this case, it's identical, so we would say this evaluates to true. After that, after we've done that for all the equality tests, whether they're equals or not equals, for example, we would then continue with each and or statement inside parentheses and solve those next. So here, for example, we have testing equals testing, so that's true. We have Python equals fun, that would be false. Once we have evaluated that, which is the first step, we would next take a look at the and or statement. Here we have an or statement, and now if we compare true to false, we have true or false, and that would be true because one of the two expressions evaluates to true. After that we can take a look at each not and invert it. So basically, once we did the evaluation here, we know that this entire statement here is equal to true. And here we have a not in front of it. So not true would equate to false. After that, we take a look at any remaining and or statement, which we have here, for example, and solve it. So for instance, since this evaluated to true and with not it evaluated to false, we have false here, and in the front we have 3 equals 3, which is true. So we compare true and false, which evaluates to true. And so when we are done here, we should have either true or false as a statement. So if we take a look at this here, here's another way to break this down. So for example, here we have an expression 3 does not equal 4 and not, and then in parentheses, testing does not equal test, or Python does not equal Python. So to solve that, we can start actually on the left side if we want to. We can evaluate 3 does not equal 4, which is true because 3 is not the same as 4. And then we can take a look at, so that would be the expression here, and then the remaining expression would be and not, and then whatever is here in the parentheses. So we can take a look at testing does not equal test, which is here, which evaluates to true because these are different strings. And then we have true and not true, or Python equals Python. Now next we would evaluate Python equals Python, which is true. Then we would take a look at and or in the parentheses, so it would be the middle statement here, which is the or statement here. So we have the expression that evaluates to true, or another expression that evaluates to true. So we have true or true, which is true. Then we would find the not before it and invert it, so not true is false. And then the remaining statement would be 3 does not equal 4, which we already know is true. So true and false would be false. And now we know the overall expression evaluates to false. This is a general approach we would take. So let's go back up and let's take a look at all of these statements. And let's try to figure out the solution first. And after that, we can run it in the Python interpreter to actually validate if what we are thinking is the correct answer is actually the correct answer. So the first statement here is true and true. In this case, it's pretty clear that the answer should be true because we have true on both sides. And if we have an AND Boolean operation, then actually all parts of the expression have to evaluate to true in order to be true. So just to double check that, let's open the terminal. And from here we can then type Python 3 to open our Python interpreter. And now we can type in exactly that statement, true and true, and as we said, it should evaluate to true. So that's indeed correct. Next we have the expression false and true. So in this case, we have false here, then the logical operation and then true. And we know whenever we have AND as a Boolean logic operator here, then all parts of the expression have to evaluate to true in order for the entire expression to be true. Since we have false here, it would definitely evaluate to false, because false and true, in this case, it's not all true, so therefore here it would evaluate to false. So let's double check. And indeed it returns false. After that, we have 1 equals 1 and 2 equals 1. So let's take the approach we learned about before. First of all, we're starting with the equals or does not equal expression. So 1 equals 1 evaluates to true, of course. And then let's take a look at 2 equals 1 that evaluates to false. So we have true and false. And just the same way as we evaluated that the second expression evaluates to false, this one will also be false. Because of course, if we have true and false, then we would take the false statement because not everything is true in this expression. So let's type this out. 1 equals 1 and 2 equals 1, and that's indeed false. Next we have a string comparison. So test equals test, and since this is spelled the exact same way, that should evaluate to true. So let's type this out. Test equals test, and it does evaluate to true indeed. After that we have 1 equals 1, which is true, or 2 does not equal 1. So 1 equals 1 evaluates to true, and 2 is not equal to 1, that's also true. So we have true or true. So that evaluates to true. And actually, if we are reading that, since we have the or logical or Boolean operation here, we already know that only one of the parts of the expression has to be true in order for the entire expression to be true. So if you just take a look at 1 equals 1 and that evaluates to true, and we only have an or statement and another expression, we technically don't even have to check the second part here because the first one is already true. And therefore, because we have an or statement, it will definitely be true in total. That would be different, of course, if we had an AND Boolean operation in here. In that case, we would have to check all parts of the expression in order to say whether it would be true or false. At least as long as the first expression here is not false. So if the first one would be false and we have an AND statement, then we can already say that the entire expression will be false because all parts have to be true. So let's type this out here. 1 equals 1 or 2 does not equal 1, and that should be equal to true, and indeed it is. Next we have true and 1 equals 1. So true is it's obvious, it evaluates to true, and 1 equals 1 does also evaluate to true, so true and true would be true, of course. After that we have false and another expression. And here we have exactly that case, because the first part of the expression is already false and we have the Boolean AND. We already know that the entire expression will evaluate to false. But let's double check it just for completeness. So 0 does not equal 0. That of course is false, because 0 does equal 0. So we have false, and that would of course evaluate to false. So let's briefly double check in the Python interpreter. And indeed it evaluates to false. After that we have true or 1 equals 1. Again, because we have true here and an or Boolean operation, we already know the entire statement is true. But that being said, the second part, 1 equals 1, is also true. So true or true evaluates to true. After that we have a string comparison. Does test, the string test, equal testing? And while the first 4 characters of testing are the same as test, the entire string is different because we have the ing here at the end. So therefore that should evaluate to false. And indeed it does. So it really has to match in its entirety when we are comparing strings. Next we have, does 1 not equal 0 and 2 equal 1? So 1 does not equal 0, that part is true. But because we have an AND Boolean operation, we need to check the entire expression. So does 2 equal 1? That is false, of course, and therefore the entire statement will be false. So let's type that out. And indeed it is false. Next we have test does not equal testing. So it's basically the opposite of the expression here we had before. And we already know that this expression here evaluated to false because it is not identical. Now if we change that Boolean operation from equals to not equals, we should get exactly the opposite Boolean result back. So instead of getting false here, we should get true. And of course we also know that test is not equal to testing. So that should indeed return true. Next we have does test, the string, equals 1. So that should be false, because we are comparing a string here basically to a number, to an integer. And that of course is something that's different. So it's indeed false. So now we have for the first time not as a logical operation in here. So we would basically reverse whatever we have after that statement. And here we have parentheses, so we need to evaluate those first. And after that we can take a look at whatever is in front of the parentheses. So in this case, not. So let's start here in the inside of the parentheses, true and false. If we take a look at that, we know that if we have a Boolean AND, then all expressions within that AND logic have to evaluate to true in order for the entire expression to be true. So is true and false true? That's not the case, because we have a false in here, so this would be false. But since we have a not in front of it, we would turn the false into true. So not false is true, so the entire expression should be true. So let's type that into our Python interpreter. So not true and false. And indeed it evaluates to true. Next we have does 1 equal 1? This one of course would be true. And after that we have 0 does not equal 1, and that's also true. So we have true and true inside of these parentheses, so this expression is true. And since we have a not in front of it, we turn it to false. So not true is false, the entire expression should be false. So let's double check. Not 1 equals 1 and 0 does not equal 1. And it's indeed false. After that we have does 10 equals 1, so that is false of course, or 1000 equals 1000. This is true, and since we have or in here, only one of the parts of the expression has to be true. So since this part is true, it doesn't matter that this is false, the expression in here is true. And since we have a not in front of it, it should be false in total because it's not true. So let's type this out. And it's good practice to type it out so we also build up our muscle memory. So indeed, this expression is false. Number 16, 1 is not equal to 10, that evaluates to true, and 3 equals 4, that is false, but since we have an OR operation here, this entire expression should be true, and with a not in front of it, we have not true, so it should be false. And indeed it is. So after that we have not testing equals testing. So testing equals testing, this is true. And that equals cool guy. So that's false because we compare the different strings. So this is true, this is false. We have an AND logical operation. So therefore the entire statement here would be true. And we have a not in front of it, so it's not true. So the entire expression should be false. Let's type this out. Exactly. So the expression in here is false and it's not false, so it evaluates to true. After that, we have 1 equals 1, which is true. And now we have an expression that's nested, so we would start inside of those parentheses. Let's just remember that this part here is true. We have a logical AND, so in order for the entire expression to be true, the entire statement here on the right side would have to be true as well. And to evaluate that, let's start inside of these parentheses. So is testing equal to 1? That's of course false. Or is 1 equals to 0? That's also false. False or false is false. And we have a not in front of it, so not false is true. So this expression here evaluates to true. And 1 equals 1 is also true. So therefore true and true should return true. Let's type this out. And indeed we get back true. So the last two ones here, we have chunky equals bacon, which is false. So we have false and another expression, and technically we could stop at this because we already know that if the expression here on the left side is false, if we have an AND statement, then in order for the entire expression to be true, both sides of the expression need to be true. Since this one is already false, the entire expression will be false. But just to go through the exercise here, let's take a look at the right side as well. So we would again go inside of these parentheses and take a look at 3 equals 4, which is false, or 3 equals 3, which is true. So false or true evaluates to true. We have not true, so false. So indeed we have false and false, which evaluates to false. So let's type this out. Indeed, we get back false. Now the last one, we have the expression 3 equals 3, which is true. We have an AND logical operation, so in order for the entire expression to be true, this one has to be true and the one on the right has also to be true. So let's start on the right side here, and again we would go inside of these parentheses and start here. So we have testing equals testing, this one's true. Or, and we already know if we have a logical OR operation, just one part of the expression has to be true. So since this one's true, the entire expression will be true. But just to check it, Python equals fun. Well, this might be true. In this case here, of course, we are comparing those strings and they are false. So this one is true, this one is false, but since we have a logical OR operation, we have true or false, which will evaluate to true. We have a not in front of it, so we say not true, which is false. So we have true and false, which evaluates to false. So let's type this out here. Indeed, we get back false. Alright, so these were 20 exercises to go through, and these logical expressions are quite important to understand because we will be using them a lot, especially when we learn about conditionals, and we will, for example, ask if a certain condition is met, or if we are working with loops, for example, and we want to loop over a certain statement of code, some expression, until a certain condition, for example, is met or is not met. So therefore it's really important to understand these properly. And here's again a short explanation what we should see. So if we print this out as we did before in our Python interpreter, then we should see the return value as we saw before. It would be either true or false. So let's take a look at some of the study drills. There are a lot of operators in Python similar to not equals and equals. Try to find as many equality operators as you can. They should be smaller or smaller equals, or for example equals or does not equal. So if you go back to our exercises from before, we can take a look at that. And for example here in exercise 3 we have an equals operator, so 1 equals 1 or 2 equals 1. Here in exercise 5 for the first time we have does not equal, so exclamation mark equals, which repeats here in the next couple lines. And these are actually the operations we're using, so equals or does not equal. In these exercises we did not use a greater or smaller or greater than or smaller than logical operation, but of course we could work with them as well. And as we can see in most of these statements here, expressions, we actually have an equals or does not equal Boolean expression. So it's really important to be able to evaluate them and to see whether they're true or false. Let's take a look at the next exercise. Write out the names of each of these equality operators. For example, I call exclamation mark equals not equal. So if you want to do that, let's just hop back to our terminal here. And we can just type in a comment, for example, and say we have, first of all here, this one, which evaluates to equals. Then we have exclamation mark equals, which is basically does not equal. Then we have greater. So that would be greater than, for example, 5 greater than 3. We have smaller. So smaller than, which is basically the exact opposite of greater than. Then we have greater than equals. So for example, 5 greater than equals 5 would be true, but 5 greater 5 would be false, of course. So greater than or equals. And finally, of course, we have the same for smaller than equals, so that would be smaller than or equals. So these are the different options that we have that we can work with. Equals, does not equal, greater than, smaller than, greater than or equals, and smaller than or equals. The fourth study drill question is play with Python by typing out new Boolean operators, and before you press enter, try to shout out what it is. Do not think about it, shout the first thing that comes to mind, write it down, then press enter, and keep track of how many you get right and wrong. Alright, so if we go back, and let's clear the screen. So for example, if we type out 5 equals, or 5 greater 5, that would be false. If we type out 5 greater than or equals 5, that would be true, because 5, while 5 is not greater than 5, it is equals to 5, and that would be included in greater than or equals. If we have, for example, 4 smaller than 8, that would be true. 4 smaller than or equals to 8 is also true. But if you have, for example, 4 smaller than or equals 2, that would be false. And this is how we can basically just test this out and evaluate it. So in the last study, we'll throw away the piece of paper from exercise 3, so you do not accidentally try to use it later. Okay, in our case, we just typed it into the terminal and we already cleared it, so we basically got rid of that. So finally, let's take a look at some common student questions. So the first one is, why does test and test return test, or 1 and 1 return 1 instead of true? Python, many languages like to return one of the operands to their Boolean expression rather than just true or false. This means if you did false and 1, you get the first operand, false, but if you do true and 1, you get the second, 1. So play with this for a bit. So if we take a look at that, for example, and we say test and test, that would return test instead of true. If we do 1 and 1, that would return 1. So in this case, it does not always evaluate to true or false. So as we read here, if we have a Boolean expression in it, so false at 1, for example, then it will return false because it compares false and 1 to each other, and false is already a Boolean expression. But if we do true and 1, we get back 1. So we really have to pay attention to that when we evaluate it, in order to make sure if we actually get back a Boolean expression or if we get back a number here. Next question is there any difference between does not equal, so exclamation mark equal sign, and smaller than greater than sign, which was also in the previous version of Python, does not equal expression. Here Python has deprecated the smaller than greater than sign in favor of exclamation mark equals. So use exclamation mark equals as the does not equal sign. Other than that, there should not be a difference. Isn't there a shortcut? Yes, any AND expression that has a false is immediately false, so you can stop there. Any OR expression that has a true is immediately true, so you can stop there. But make sure that you can process the whole expression, because later it becomes helpful. That's basically what we saw before. So if we had an expression like true or something else, we already know it will evaluate to true, because in a logical OR expression, just one part of the entire expression has to evaluate to true. So even if we have false here, it will still be true. If instead we have, for example, this false and some other expression, we already know that in an AND Boolean operation, Boolean expression, everything has to be true in order to be, for the entire statement to be true. So therefore, if you have a false and, we already know it will evaluate to false, even if we have a true statement after that. So that's a handy shorthand, which we will also use going forward, but still, of course, we should be able to evaluate the entire expression. So that's it for exercise 28, and see you guys next time with exercise 29.